Hello, my name is Anastasia Masalova, and this is my lab report on the topic of constant velocity. The main goal for the first lab was to record and analyze an object that moves at a constant velocity in a horizontal dimension without changing direction. This experiment is important for me because it shows how objects move under zero net force. Additionally, understanding constant motion is essential for learning more complicated motions later in the Physics 2211 course. Before I elaborate on the experiment and results, I want to cover several concepts and formulas that we will need for analyzing the motion. Newton's second law or momentum principle is the main concept of this lab. In the experiment, we consider friction to be negligible and assume that no other forces act on an object, except for gravity and normal forces that compensate each other. According to the momentum principle, then, change in velocity will equal to zero, which means that initial velocity and final velocities are the same. In the experiment, we will also need to know how to calculate position. With the constant velocity, final position will equal to the initial position, plus initial velocity multiplied by change in time. The experiment consisted of 4 parts. Firstly, I filmed a video of a golf ball moving on a flat surface. Then I tracked the ball's motion with the track application and put observed measurements of the position and time into a spreadsheet. After that, I created a computational model of the moving ball using GlowScript and put predicted measurements of position and time into a spreadsheet. Finally, I compared observed position from the tracker to predicted position from GlowScript by plotting two graphs on one chart. As a preparation for the experiment, I found the mass and diameter of a regular golf ball. After that, I recorded the video and analyzed it in the track application. After tracking the ball's position, I created a table with observed values of time and position. One of the important values I got after tracking the ball's motion was its initial position vector. I also calculated the initial velocity using the formula and set a marked frame and final time on the motion. With this data, I wrote simple code in GlowScript to generate a computational model of the moving object. After running the program, I observed a 3D motion of my model and analyzed two graphs, position versus time and velocity versus time. I also created a table with predicted values of time and position. Finally, I created a chart with two lines that represent two functions, the observed position function of time and the predicted position function of time. Even though the two graphs seem to be identical, the closer look shows that there is a slight difference between them. The difference occurs because we assume that friction force is negligible. However, my experiment was conducted in a non-laboratory environment, where the ball experienced friction from the surface. After conducting the experiment, I needed to give answers to two questions. The first of them asks, what will happen if the x-axis is flipped? In this scenario, ball moves in the minus x direction instead of plus x direction. The ball's position vector will have the same magnitude but negative sign. Additionally, the ball's velocity will become negative. The second question asks to discuss the forces that influence the ball. Analyzing the x-axis, we can say that there is no force that influences the object because we assume that friction force doesn't exist and other forces do not influence the ball in the x direction. The ball, however, is influenced by two forces in y-axis. Gravity force and normal force compensate each other, which as a result gives a zero net force. Thank you for watching my video. Hope to see you in my future labs.